Welcome to the first study group of February 2025. We're going to do efficient data processing. And I think we were talking in the preamble time before the study group got started today about what to do with an efficient data processing session. And I think we're gonna go pretty technical. I think we're gonna do something about how do we deal with giant data in Mule. And I have a client who I was talking to just this morning on the phone who's chosen not to use Mule for one of his large data problems, which sometimes that's the right answer, but that's more of an architecture thing. So let's assume that we're going to use Mule for this time, right? And we're going to need to deal with gigantic data. So I'm going to go ahead and share my screen. And today I updated to the latest Mac OS X, and I'm so glad that sharing screen worked anyway. So if you're still thinking about upgrading to Sequoia, at least we know that's going to work. I'm going to take the study group over here. And I called it the batch sandbox. We're not going to do batch though. Let me rename this to data. Okay, we'll just make a new little sandbox project. I still haven't started using any code builder. Are you guys using code builder for your main daily driver yet or no? Anybody using code builder more? No, ha ha ha. I mean, I'm friends with some of the, and I'm going to Trailblazer DX next month, so I'm going to see all of those people again. And I saw them in person at Dreamforce. So the whole product team for Code Builder is very interested in people like us trying it and telling them all the things that are wrong with it, and they do not get their feelings hurt. So if you want to give it a try and write down your notes, they would like to hear whatever it is. But for this, I am definitely not. I'm going to use Anypoint Studio. I did an example in architecture class that I'll probably start with here. So when you want to deal with giant data, you got a couple of ways to get started. You have to have the data first, right? And so for learning with Mule, a lot of times I generate it. I use data generators, and I had a study group about a month ago where I showed one of my data generators. We have it open source, so this is probably a good moment to bring that up. If you go to Integration Quest GitHub, there is a data generator called data generator, right? And right now, all I did was I started building on top of the data generator that is already in Anypoint Exchange to make data that was more useful for some of my use cases. And right now I have a customer data generator in here, and I'm interested in adding more generators. So a nice thing about open source is you can go make a fork of this repo and then send me a PR if you wanted to do product generators, or if you wanted to do patient generators, or something that's more related to your use case. Anyway, we could use this to generate a bunch of data for our session here. So why don't I do that file? Actually, I did that the last session, and it takes a long time to generate the data. So maybe I can go just find my output of the data. I think that would be in my desktop. Oh, here we go. This is 50,000 customers. That's still not big enough, is it? I got 50,000 customers. That's only 23 megabytes. That doesn't really count as big, does it? Another thing I have the results of a web scrape I was just doing, and this is a couple hundred megabytes. So that's not too bad as a data source, right? A lot of times when we're working with big data in Mule, it's going to be a whole bunch of unstructured stuff like this. I did a bunch for a Speedway project I'm working on. Another thing I could do is we could generate audio data. Well, I think we only got like an hour, so let's just generate from scratch here, right? So I'll start like a little process. A lot of times you're doing data processing in Mule, you're going to have something that's run by a scheduler, right? And then the way that I would like the study group to work is you guys, when you see something that's like, hey, that's a spot where I want to learn more about it, you can stop me and ask a question, and you can help me like decide how far we go down the road. This is just going to be the generate input data, and I'm going to use the file connector. So we're going to use the local file system for this one. everything I do here with the large data would work fine with S3. It would work fine with HTTP. It would work fine with the database. Nice thing about Mule is it doesn't have to be, your code doesn't have to care where the data is coming from or going to, right? So we're just going to use the file connector as like a start. And I'm going to put the data in some files. So I'll start with a transform, right? And this is going to be make lots of input data. And probably what I'll do is I'll take that 50K customer file. We'll go read it. And I'll have this available first. So this is going to be my, where did I put it? So this is going to be, I'm going to basically multiply my data by a lot. So on my desktop, I've got this 50,000 customers, and it looks like this. So this came from the open source data generator you just saw. It's kind of realistic looking stuff, right? You got a name, you got an address, you got a contact. I did some stuff with invite codes and sign up dates. So it looks like a bunch of customer signups maybe. So I'm going to go read that to be my source data, my starting data. So let's just do that. There we go. And I'm going to read it as JSON. And that's all I'm going to do for now. So I have 50,000 customers here, and I want to make a lot more customers. So for now, I'm going to do var count is equal to 10, just to kind of get my generator working, right? So I'm going to take the input payload as array, right? Because the input is, let's just make sure. Where did it go? Customers 50K, right? Is it already up? Where did it go? There it is. There's my customers. Open with Sublime again. Yeah, it's an array, see? So I can take that input array and get some items out of it, right? So we're going to do 10 items from the array. So I'll use, what I'll probably do, this is going to be source customers is equal to that, right? And then I will, however many count I have, 1 to the count, right? I'm going to go get a random customer, right? So source customers, square bracket, random int, source size of source customers. There we go. Now it doesn't know expecting type array number, got array of any. Oh, it's annoyed. 1 to count as array. I just want to make the type system happier. Now this says array of any. Well, it's not an array of number. I don't care. As array map. That. All right, and then what I can just so I can test my generation process, let's log what we got. And run it. You don't want to go too long on one of these generation things without seeing it go. All right, looks like I've got plenty of random customers. Let me hit stop because it's doing it every second, right? So I can now generate as many customers as I want. It'll have duplicates, but what do we care, right? So what if it has duplicates, right? So let's just do a little math estimation. What Encounter brought up is let's deal with when we've got really big data, right? So if I multiply 23 megabytes times 100, I'm gonna have, well, how much, right? Put it in the chat. If I make 100 of those, I'm gonna have 2 gigabytes. That seems like a good, decent amount of data to work with, right? And if I look, I can even make my Mule application run with a very small amount of memory too. So let's cram it into 500 megabytes, right? So dash XMX. We're gonna make Mule run with 480 megabytes memory, right? So we're gonna generate 2 gigabytes, and we're gonna try to process with not so much RAM, we're going to need to use something called streaming to do that. So that's a good lesson, right? So let's make this times 100. So 50K times 100 is 5 million customers. Is that right? Would be 2 gigabytes. 5 million customers, 50,000. Yeah. So we're going to do 5 million customers like that. And this will, as I just wrote it, this will be the first time that we break Mule because we're going to run out of RAM, right? So let's show that first, right? I'm going to make this run a little slower. We're going to run one time, basically, just to get the thing to break. Here we go. So we're going to generate 2 gigs of data, and we're going to run with only half. Uh-oh, what just happened there? Did I misspell the option? Probably. Initial heap size set to a larger value than the maximum heap size. No, I need to do 2 settings. Okay, so what happened was I told it to use maximum 480 megabytes, but it starts higher than that. So I'm going to make it MS. And you can Google. I just happen to have done this a bunch of times. Normally, I would go Google and look up the settings, but so it's a good thing for the short study group that we don't have to look that up this time because I have memorized it. But all right, now we're running, and I'm expecting to see it break. I didn't put any logging in. Maybe I can see the RAM go up. Let's see. Oh, I've got some other stuff open that's getting in the way. Let me get rid of that. We're not doing Java today. Let's see. So here's a Java process. I wonder why. Okay, I can't tell if I messed up getting it. I'm trying to make it break, and I can't tell if I did. So reading input file, and then generating data, another logger, right? And then at the end, we're going to output the payload. So we never saw the output, but now I want to see the steps happen too. So we're going to restart it. All right. Oh, it was trying to shut down and it was having problems shutting down. All right, let's do this again. Okay, it's generating data. I did not expect it to take that long. Well, I don't want to wait the whole study group for the data generation. So let's do the first part of the lesson, I think. Right? That'll be good. So what I'll do is I'll generate it to a file instead of RAM. This is going to fill up RAM. It's just too slow to fill up RAM, right? All I would have to do to make it fill up a lot faster is I would have to make the transformation not use input, just generate some stuff from the computer. But let's see how long did this go? This is going to go a while. So yeah, we're going to do a write file right here. I'm going to skip the logger step basically because it takes too long. So we're going to write out to customers giant.json. All right. And currently, Mule is not going to be able to do that. I'm going to do like this. I think what's happening is because I'm doing the random accesses, it's having to do a lot of work. So I don't actually need randomness here. So instead of doing, what if I just do 100 copies like this, right? So instead of getting a random item out of the customer, I'll just take the entire source customers and join them together. So 1, 2 count as array map. Oh, I know what I can do. I can just take the payload And each item in the payload, I can copy it that many times, right? So one map customer, one to count, and this should be a flat map. One to count customer. So all I'm doing is making 100 copies of each customer and just making a giant, I'm just expanding the size of it, right? So this is going to be a lot less work for the computer because this is still going and I don't want to wait for it. on some of my own work, when I'm not like, I will wait for it to see how long it actually takes sometimes, but let's improve our how long this takes us. And we're going to make a giant file. Stopping, and it's having trouble stopping. Here we go. Even now, I want it to, I'm trying to get it to pop. So let's see, generating data. And as far as I know, we're not going to have any, oh, look at that. Customer's giant is 508 already. Oh, it finished. I didn't put a logger there. That was really fast. Let's put a logger at the end. Finished. I just want to see it, right? Oh, that got bigger. 2.35 gigabytes already. We predicted that, didn't we? Finished. That's how long it took. Okay. So what we just did was we took the data, the 50K records, and we wrote them out to a file. And I'm not happy that we didn't have a crash because I tried to make too much data. We have a 2.32 gigabyte customers giant.json. Let's do it like this. Tail dash or head dash in 100 desktop slash customers giant.json. There we go. So this is the first 100 lines of that file, and it's that guy repeated a bunch of times. Arc, 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 arc. Okay, so now we got something to work with anyway. What I was expecting to have to do was stream. So I think what must have happened is it automatically streamed that deferred mode. How do I make it? What if I do 500? I'm surprised it didn't use all my RAM. So what I want to do is overload it. So now we're doing 10 gigabytes. And I am on 4.8. So what I'm expecting might be an older version of Mule. I'm expecting breakages and it's not breaking. Let's see. I don't know how quickly Finder updates either. Because the last time it ran, how long did it take? It took, what was that, like 15 seconds? This time, so if it's 5 times that, it'll be 75 seconds, right? And if it doesn't break anyway, we're just going to have a really big file, which is nice. It's a good starting point. So I can actually begin the next process. And what we're going to want to do is process that data somehow, right? I don't want that big of a file. Oh, I can afford it. We can do it. So this will be process huge data, right? And we're going to read from the giant file. And did it finish? Okay, it finished. So it took just about 2 minutes to process. It's 10 gigabytes, right? Or it's still 2 gigabytes. Why is it only 2 gigabytes? Is this wrong? I bet you it's wrong. It has that little arrow. Oh, because it's uploading to my cloud storage. Ha! I shouldn't be using this folder. Yeah, it's 10 gigabytes. And I'm going to delete it, and we're going to use a different folder that's not going to upload to iCloud, because this is dumb, right? So let's take that off of there, and let's do another one. And I don't think we need 10 gigabytes, right? For that, we could go a little smaller. Let's go back to 2 gigabytes, I think. And let's put it in /temp. Let me make sure. I think I have one. Okay, good. I'll make a study group folder, and we'll put it in there. There. One more time. Customers giant.json. All right, good. And then we'll read from there. And we're going to want to process this data, right? So let's do something real simple, and just, what if we just log all the lines for now? Do something simple, right? So we'll do a for each, and we're going to log like everybody's name, right? Log the name, right? So this will be MIME type of JSON. And we're going to log customer name is whatever it is. I forgot my data model. Customer.name.first, customer.name.last, right? So we'll do that. Payload.name.first space payload.name.last. And inside of for each, we have a counter, right? So I could even number them. So all right. And stop the whole process. What we can do is move the scheduler down to the process huge data flow and see what happens. All right. I'm going to fill up my logs pretty quick, huh? And why is it taking a long time right now? Think about that. I can make it more obvious too. Let's put a log here. Starting processing giant file. Save. Because now it's going, right? There goes all the names. I stopped it because it's reading a huge file. You know, the chat doesn't tell me who's talking either. It's just it's just somebody, whoever wrote that. I think you're right. So I'd like to see what the delay is, right? So it said started processing giant file at 11:28 Central Time, United States. Let's see how long it takes to read the 2 gigs. And there it goes. I'm going to hit stop now so I think it's too late. I think I missed I think I scrolled out of my logs. Let's see. I won't have the beginning anymore. Yeah, it's too late. Well, it was 10 or before it started processing. You can get it to go immediately. You can get it to start at the top, right? So you can take this file and you can change the read mode. You can add a parameter called streaming, and it'll start without waiting, right? So I can go true, and then we can do something like, how am I going to do this? I want to see it, right? So let's do like this. Let's take the payload and let's do it in pages of 100 people, 100, or we'll do pages of 500. So we'll do 500 rows in a row, and for each 500, like that. And then what I'll do is I'll put a logger. Let's see. This is going to log just one, right? Right now I'm going to get a. So let's take the. Let's take that and put it in another for each. So now I'm going to get a page of 500, and then for each one I'm going to log the name, and there we go. Processed a page of 500. Right? We can paginate, right? And what I'll do is I'll make that delay so we can see the process go slow, basically, is all I'm trying to do. So let's put a little delay in here. DW runtime wait. I hate that this is recorded. You're never supposed to use wait, but every 2 seconds now, the logger is going to complete. So I'm slowing it down. So log and wait here, right? There we go. So that way I can kind of see. What if I do this? What if instead of, I don't need to print every single one of them out, right? What if I just print whatever names are in there? Let's do because bars.counter is going to be a page now. So now it's going to be page of this, colon, and I'll say, what do I do here? I'll just take the first item. First customer is that. And we'll just take the first item from the page. I'm going to get data weave errors if I didn't do this. All right, cool. Now I can run it. I don't want to have so many lines in my log. Run again. This is going to show better, right? Yeah, there we go. So page 1, see that? Page 2, page 3. So it's processing pages right now. And when it started the process, did it print out that it started the process? It didn't even print out starting the process. How did this mess up? Starting process giant file didn't show. Oh, there it is. So it happened at 11:32:23. That's pretty quick. So it looks like it's streaming right now, right? And it makes sense that it's streaming. It makes sense that we're seeing this process immediately, because there is no way that we're going to fit a 2 gig file in 480 megabytes of RAM, right? It's too big. Let's see if I can prove that with, looks like I've got 3 Java processes running here. Oh, they're not 2 gigabytes large. Let's do this one. This one is, get out of here. This is not Mule. Open files is, oh no, this is Mule. This is the MuleSoft. Okay, good. So here's my Mule process right now. We're using very little CPU. I don't want to quit the process. And not 2 gigs of RAM, right? So it must be streaming the data from the file, right? Because it's processing pages right now, 500 items at a time, without using RAM, right? Let's see what happens if we turn streaming off, right? So all we're going to do, I like science experiments, right? So I'm going to go back and I'm going to turn it back to false. We'll change one variable and observe our results, right? So now streaming is false, or you could leave the setting off. It's the same thing. And so let's see, starting processing at 11:34:45, and it's kind of sitting here, right? It's just sitting here. Let's see if activity monitor tells us anything else too. I don't see any RAM usage change really. Well, this one changed. I think it took 2 minutes last time, didn't it? Well, that's a long experience. Okay, now there you go. So it took 30 seconds to get started reading pages, right? Now, I think I know why it didn't crash. I think I know why it didn't crash. So let's go do a little bit of Mule documentation research here. There's a important what we have to pay attention to when we're trying to determine what Mule is going to use for RAM is what kind of data is being read, right? By the for each, because for each is looping. That's what's reading data, and it has to read the data based on the MIME type. It has to use this MIME type to know how to do it. So what these parameters do is these configure the DataWeave format engine. DataWeave is doing the reading of the data. It has to, right? It wouldn't be able to know what the array is. It has to parse the JSON and find pages of 500. So in the DataWeave docs, you're going to find a list of formats. Is it reference or language guide? Data formats, right? So here's all the formats, and we know which one we're using is JSON reader, right? So go to the JSON format, and you'll see that the DataWeave reader for JSON supports the following parsing strategies, which is exactly what we're doing right now, is we're parsing data, right? And there's an in-memory strategy, which we are really not using. Right? How do we know we're not using the in-memory strategy? Right. Well, let's look at our evidence. We're seeing the process continue to run, right? So it's definitely processing the data, and we're seeing that we're using no more than 940 megabytes of data. And the last piece of the puzzle is our file is how big? Our file is temp study group 2.37 gigabytes. So you can see it all on my screen right now. We have an input file that's 2 gigs. We have a Java process using 900 megs, and the process is working, right? So it definitely doesn't have that whole file in RAM, right? Agree? It's certainly not using the in-memory processing strategy, right? And we know it's not using the streaming processing strategy because we turned off streaming. So the only one left is indexed. Amrit got that one. Yeah. So JSON can do indexed, right? So if you're using another format, CSV, and it has all 3 options, it can handle some processing without exploding the computer by using the disk, by indexing on disk the data, right? And DataWeave does that internally from formats, but not for all formats. What happened here? I'm gonna hit back. There we go. Now, if you look at, there's other formats like new line delimited JSON, which I use a lot with Google processing. It doesn't have indexed. It just has in-memory and streaming, right? Or if we go to XML, that one has all 3. What about Excel? I think Excel is another one like that. Microsoft Excel, only in-memory and streaming, right? So if the format only supports in-memory and streaming, you can't load a file that's bigger than RAM unless the only way to do that is streaming with those formats, right? And then some of these formats, they don't even support streaming at all. So if you have flat files from a mainframe or something, you can't stream, right? You have to do something else. So those are our this is the first thing you have to determine. You imagine, any computer program, if you need enough resources to handle the data, you have to start with where's the process that loads the data, and what is that process's perform, how much RAM is it going to need, right? And you have to use the formats here to determine that. So we're processing this thing in a streaming way. Now, what if we didn't want to loop over the data? What if we wanted to transform it and write it to somewhere else, right? DataWeave also has a streaming output mode, right? So we were just looking at streaming input. But what if I wanted to, I don't know, turn it into CSV first? That'll be fun. Let's do that. So this would be payload map. Now CSV can only have one level of, it can only have, that's too big. Let me go look at a smaller example. I need my data model again. CSV can only have one level of keys because it's columns, right? So if I look at one of these, I have name is an object, address is an object, contact is an object. So if I was going to make a CSV file, this data model doesn't work, right? So let's go ahead and fix it real quick. Let's do first name is, and in CSVs, they tend to go in Excel, so you can do something like this. Let me do row, or this would be customer. There we go. Customer.name.first, right? Last space name, customer.name.last. What else would I put in there? Phone number, right? So we put phone, customer.contact.phone, and then what else? Let's see. Email, right? Put a few fields. Customer.contact.email. There we go. So we build a CSV file, and now we're going to try processing that at the next step of the flow. So now we would not do, now we would do payload sub0 dot first name, and this one will be last name. And maybe at the end, we'll go write it to another file, right? There we go. So we'll go put whatever this is in /customer data.csv. Yeah. Sounds good. And maybe what else I should do is not slow it down anymore, right? So I'm going to get rid of the slowdown so it goes faster. Here we go. Still chugging through pages there.
Hey, Ryan, this should fail, right? Because when you're streaming, you can only read the data once.
Well, I'm not streaming, right? So yes, it should fail because I'm not streaming, right?
Oh, okay.
Yeah. And and if I take the transform out, it won't fail because the file write might actually fail. But yeah, somehow it fails. So we're gonna let it fail, and then we're gonna put streaming in.
Okay.
Yeah, I hope. Let's see if our prediction is correct. I like that, Amrit. The prediction is we're gonna explode. So the for each is doing fine without streaming, right? Because of the indexed reader.
Yeah, if it's not streaming, I think it should be fine. I think when you change it to stream, that's where it should fail.
No, it will. I'll show you why that won't. That's okay. Okay. It's not a Java input stream. It's a Mule repeatable stream. How many pages are we going to get? I'm going to show that. I was planning to do that part here. I'm a little bit. I forget how many numbers we have here. We have 100 times 50,000. Okay, 10,000 pages. It finished. And we should now have a. Wait, I need my temp directory. Now we have a customer data.csv that got output. So it didn't fail. It didn't fail on the right. Maybe because this is too small. Right? This is not much data. I'd have to use more. I don't want to use more though. We could put more fields in though. I need to make it bigger. I could make it bigger artificially, right? I could say big data, big column, and put some large string in there, right? So let's do like this. I'm cheating for the class, of course, but import star from that, and we'll just repeat 10,000 X's there. So now we have 10,000 X's on every row. That should make it bigger, right? Let's see if what that does. So we just made every row huge. This is I'm not going to hit save because I don't want to restart again. It's so slow. What did I do to slow it down? That's not a very intense. Oh, I have streaming off. So I guess having to. Oh, we're watching. We're having memory pressure? No memory pressure. So my expectation is I'm expecting to have to turn streaming on for this to work, but I'm not seeing it break. That's what my hypothesis here. We started processing the file. We read it. We put it through this transformation with a big X, big column. And we started that over 2 minutes ago. Are we seeing an output in the file either? No, see, this is not writing. It is risky to do a big data study group because sometimes it takes a long time to process big data. Let's see what we can figure out here. 5:47. That's over 2 minutes. See, I don't know why it would not have already shown memory pressure. But I'm having no increase in RAM usage, and it's taken too long. Well, we've already seen it wait, so I guess if I turn on streaming and we see it proceed faster, that'll at least show that there is a difference with streaming, even though we haven't shown Mule crash. It's always fun to make Mule crash in a class, but let's I hit stop. Let's go ahead and make it streaming and see the difference, which is where I was headed anyway, right? We're going to make a streaming true. And on the transform, we're going to use a mode called deferred. So if you want to transform output, you have to, there's a web page about this, streaming in DataWeave. You have to turn on deferred mode for your DataWeave transformation. And then it'll transform as the records pass instead of the whole thing at once, as long as the DataWeave functions you use are compatible. So we're going to do deferred equal true. And why is it telling me that? Oh, I'm just going to try to make the type system happy here. There we go. And we'll try it with deferred mode now and see if there's a difference, because that was taking at least 2 minutes stuck on this before beginning, right? So I think we will see a difference there. But let's see if I'm right. Hypothesis, experiment, results. All right, there it goes. It's already going. See how fast that went? Because we're streaming the data right through the transformation. And I think if we look, I don't like the array, by the way. I don't have to fix that one, but that's just a logging thing. We should already see the CSV file growing. I don't think Finder's fast enough. So no, it's not streaming into the, oh, of course it's not streaming into the file, because the for each has to finish before it begins writing the file. So you know what we'd see? It'd be cool to see them go in parallel, wouldn't it? Because like you said, a stream is not normally something you can do more than one thing with. But we don't have to wait till the end of the for each. We could actually do a scatter gather right now, right? Or an async or something, right? And just do them both at the same time. That'd be interesting. Oops, I want to do the looping inside. There we go. So we're going to write the output file and loop it and log in parallel. And that would be fun. And that's happening because Mule internally uses this repeatable stream implementation. So I went to the read operation where I produced the file, and I went to the advanced menu. You're going to see the streaming strategy. There's some choices there. We could talk about those if you want. But if I use a non-repeatable stream, like Amrit was saying, this process would not work, because one of the processes is reading the data and the other one won't be able to read it. It'll be gone, right? But Mule has an internal buffer when it uses file store stream. So it's going to go put that data, the stream data that it needs, in a file while it's running. Uh-oh. What's it upset about? Payload can be transformed in order to copy it. Okay, scattergather doesn't like that anymore. This is a new error I didn't see in 4.7. Cannot copy message with stream payload. Payload can be transformed by using a data wave transformation in order to be able to copy the message. We already did that, though. Oh, because this one is, aha. This is a stream. I thought I did that in 4.7 though. So I wonder if it's deferred mode. Because I think what I can do is I can do this. I can put the transform here. Then I just need to change my logger back. This one is not. I think it'll copy that one. So let's see. Let's see if I'm wrong. Right. It wouldn't do it the way I had it the first time. Payload.name.first. There we go. See if we can get it to do that. That was an interesting failure. I've never seen that error before. This is probably because I'm on 4.8 now. Whoa. What's it logging? Oh, because the name is an array. So basically it is working, but it is too noisy. Can I see the beginning of the process? Yes, I can. Let's go back to the beginning of the process. Processing giant file began processing rows immediately. I needed to go back to the first item. That way I don't have all those names. And this is deferred mode, right? So we should see, yeah, it began writing the CSV file before I killed it. See, now it's at 93 megabytes. So if I do it again, I would have made it a little less noisy. I think what that means is, okay, I think what we just learned was this. It's exactly the repeatable stream lesson. So this repeatable stream is not a normal Java stream. And what it enables is what we're seeing happen in my logs. We can see two processes running in parallel on input right now, right? One of the processes is the one that, let me see, here's the beginning of the process, starting processing giant file, and then it starts printing out pages immediately with the for each 500, right? Very, very much. In parallel, which I should have put a logger there. Let's add one. This will be done writing CSV file. In parallel, it is, let's see how this looks. It looks like it's still now, see that? 220, 227, 248, 261. It's writing the CSV file at the same time, right? So it's reading the stream in with two separate processes that are consuming it as fast as they can, and it's keeping a buffer so that they can both run at the same time. That's repeatable streaming. And when we added the deferred mode in, it stopped working, right? So stream directly, you can do multiple consumers at once. These are, each route is a consumer, right? But as soon as I add one of these in here, even if it does nothing, right? Even if I just take the input and I output it, right? If I put deferred equal true, we won't have a repeatable stream anymore. Now we're going to have a piped input stream, and it'll break the process. That's what we learned. So this data weave streaming output, so hold on, streaming output will break this because scatter gather needs to consume the stream twice. Confirmed, and that's what you were expecting, right, Amrit, when you brought that up?
Yep, that's right.
That's it. So our way out is to use the repeatable stream directly as the input and do our transformations inside. Right? That's our solution. So let's go back and there we go. So we read, what did we just do? Wow, that's pretty cool, right? Let me get rid of this broken thing. We read a 2 gig file. Let me put this on here so we get a nice little screenshot. Somebody can, is Rook in our meeting? I don't see Rook here. Shoot. We can put this in the thumbnail of the YouTube, right? We read a 2 gigabyte file, and in parallel, we paged 500 at a time and did something with it. We could write other files. We could call S3. We could do whatever we want. And at the same time, we transformed it into CSV and wrote it to a different file, right? Because of repeatable streams. And we had to put streaming equals true on the read in order to do it. Let me put that on here too. 2G streaming, right? And this one was streaming output. I'll put streaming output.
Brian, so is there any way to get a repeatable stream like you get from your read operation out of a transform?
Well, I would have been much less certain before this study group. I think we learned together today that the transform produces one that is not repeatable. And there's no configuration. It's just you can turn it on. That's it. Right? So deferred writer property makes a output stream that is not configurable. Let me go to the streaming output part. See if maybe I'm missing something. But I do not think there's a significant sacrifice we make to do streaming output. I think Hardy, that's exactly the limitation we're proving out here is once you stream the output, it is not repeatable. So is there any way? I mean, you could write a file. You could go to a VM queue or something. You'd have to put it through a connector that does produce repeatable output streams, which is a very big sacrifice. Yeah. All right. What else could we do with this? I don't really want to. We've already gone an hour, so I don't want to get into batch in this one. We should do batch in a separate study group. So what else about big data? How does this match up to challenges you ran into on your own?
I don't have a challenge for you to demonstrate. What I can speak to is we had a mainframe transformation.
Yeah.
And my developer on that project was probably less well versed with data weave than he initially indicated. So I ended up with him writing Java components and bringing that in.
Yeah.
And it was a big file that we had to do some cleanup on.
Yeah.
Sorry, go ahead.
No, I agree, and I don't think I would put it to his experience level. There are limitations.
Well, no. So the original Java code executed.
Go ahead.
The runs over 5 hours to do the file cleanup, and it was not something that is significantly complicated. I've rewritten that in data weave and gotten the runtime down to 22 minutes.
Oh, okay. No, yeah, you know for sure that the data weave was, but I guess at the beginning of the process, mainframe input can't be streamed, and unless it's
It was
JSON.
we were just getting exported files, right? We were just getting very large CSVs.
Oh, they were CSVs. As long as they're CSVs, you can stream them. Yeah, I've been wanting for a long time for flat file to be streamed. I think it's very sad that we can't stream flat files from mainframes. So yeah, you had, and what were some of the, so going from a 5-hour runtime to a 22-minute runtime, we may be able to, do you have any maybe choice design changes that maybe the rest of the people here would learn from?
Well, I did turn streaming on. I mean, I understand what you're saying in terms of making some sacrifices, but it feels to me like you always win on performance if you do that. Depends on the complexity of the operations you want to perform, I suppose. And then, keep it as simple as possible. Going out to write Java file handling was just wasn't the right choice. Very often, data weave is so well put together for data handling and transformation that there's so many things I see implemented that people go through multiple operations when really there's already a function in data weave that we don't use it every day. We're not as familiar with it. So we assemble the same thing, but there's actually already a specific function for it. If you take a little bit of time to go dig in the docs and go, you find something that's probably more performant and already written to do exactly what you need.
I got a couple of nuggets there. These are good ones, right? And it's already, and I can confirm that when you use a core library function, many times it's implemented in Scala. It's not implemented in data weave. It's implemented underneath the hood in Scala. So even something simple like a reduce instead of a recursive function call might be way faster, right? I found an example of that one. I think I did it in my last session, so I'll just talk to it. So for example, I have a proof of it though. I have a little nugget of data that proves it. Object field lookup is over 10 times faster than array searches, right? So if you have an array at the beginning of your data weave transformation, and you can transform it into an object first, so that lookups don't have to search the array, you're gonna have a 10x plus performance improvement. So that's like that's what I mean. Like sometimes there's core library functions, including that are gonna incredibly be faster than building your own clunky little function. You know what I mean? So I'd agree with those for sure. Thanks for that. I like the real world experience. Yeah, for the but somebody put login time versus n in the chat. Yeah, exactly. It's O log n instead of O log on. But even for small, like I think I had like 1,000 or 1,200 items in my array. The object lookup was so much faster. That's not even that much data. You know what I mean? Like a list of U.S. states or something. You know what I mean? Like 50 of them. I still think it's going to be way faster. So very good. We didn't talk. There was one more part of streaming we didn't touch on that I should go back and do, which is here. I'll show you here. We'll do it here. Canada will be faster because you have less states. That's funny. So let's do one of these. If I did payload order by $.name, right? So let's make a couple of items in here. Here we go. Name is Amrit, right? And I'll make another one. Name is Hardy. I'll make another one. Name is Brianna. There we go. So we're sorting it, right? If I want to put this in deferred mode, I'm going to break it. And it's not going to work so well in the playground, but I want to know that before I run the code. Deferred mode is not compatible with all DataWeave functions. Some functions are not stream capable, and you can tell that. Like if I go to the DataWeave reference, where is it? Here we go. I go to the reference and I go to like the core library. Let's just look at the map function. You'll see something funny in the documentation. You'll see this annotation, stream capable, written in the method signature in the documentation. And it's real easy to just think that's noise. I don't need to look at that and just kind of skip over. But this tells you that the map function can be used in deferred mode, right? And if we go to the order by function, you're going to see the opposite of that. There's not a stream capable here, right? So some functions are compatible with deferred mode and some are not. And you can tell DataWeave to check your code for you. Here, I'll do it here, right? So if I want to make sure that I need some record. Yeah, exactly. A deferred one. That's exactly why. Sorts in general have to be random access, right? So you can switch the order of things. So I want to ask DataWeave if order by will work, right? So I can declare that my input is JSON here, and then I can annotate my input stream capable, and the DataWeave engine will tell me that I'm invoking a function whose parameter is not stream capable. It'll check. It'll use it'll use the type system to warn me that I'm writing a transformation that can't be streamed, right? If I change it to map, it is fine, right? If I do filter, right? $.name equal to Brianna, right? It is fine, right? So some functions are stream capable and some are not in the core library, and you can annotate your expression so that it'll catch you and tell you, hey, watch out, you're doing something that we can't support, right? So if I did order by again, or there's a few others, like I think they just made some by stream capable. Group by, that'll be another one, right? I did this wrong again. Here we go. Group by, that's definitely not stream capable, right? So it'll give you the warning, parameter payload is not stream capable. So if you're going to do streaming, you got to watch out for that one. Man. Well, I hope this was worth Friday afternoon lunch break. And we could dig into a little bit of dealing with large stuff in DataWeave. I could probably put this code up on GitHub so you guys can download it. I'll put a note in the study group session on the course, but let me take this off and just thank you guys for coming. Any last comments or recommendations for future sessions? I'll be interested in what else we could do on one of these Friday sessions.
That was awesome. Thank you. Happy to learn.
Yeah, thank you.
Happy to take down some notes.
Great. Well, I hope you guys come back to the next one. And if anybody wants to do one, I always let other people, if people are interested and they have something they studied, the rest of us might be able to learn from each other. So thanks for coming, everybody. We'll see you at the next study group.
Thank you.
Ryan.
Thank you.
You're on. Have a good weekend, guys.